Hello all. Today we discuss about 8085 serial input output lines, which is named as serial output data SOD and another is serial input data SID. Using the SOD and SID line, we can interface the serial data transfer from microprocessor to any other peripheral devices. So 8085 has two pins specially designed for software controlled serial input output. One is called serial output data, also known as SOD, and another is called serial input data, which is also known as SID. Data transfer is controlled through two instructions. First name is set interrupt marks by the instruction and read interrupt marks, RIM. These two instructions are available. Instruction SIM and RIM are used for two different purposes: interrupt and serial IO. So in this chapter, in this tutorial, we discuss about the serial output data, how serial output data is formatted using SIM instruction. So basically the instruction SIM is necessary to output data serially from SOD line, and shown in the when SIM instruction is executed, the accumulator bit pattern is look like that. This first bit is known as SOD, and this 6 bit is the 7 bit and 6 bit is known as serial data enable. So this pin is enable the serial data communication. If this pin is 1, then enable SOD, and if this SD pin equal to 0, then this SOD line is disabled. Okay, and remaining bits are not used. Remaining bits are used for the interrupt process, but in this video we only talk about the serial data transfer mode. Okay, so how serial data transfer mode? So let us discuss about that. Now first of all, instruction using SIM. So if we transfer logic 1 and logic 0 simultaneously, so first of all logic 0 is transferred, this is SOD, and this is 1, and remaining bit are don't care, that means remaining bit are 0. And next one is the data is 1 and this should be 1, remaining bit are don't care, so that is the format is 0 1 0 0 0 0 0 0, and next format is 1 1 0 0 0 0 0 0. So the first, from the first format, the hexadecimal code is 40 and second C0 hex. Now we write a code MBI A, 40 and execute the SIM instruction. If the SIM instruction is executed, after SIM instruction is executed, the accumulator content shows that this pin is 1 and this pin equal to 0. So from the output line SOD pin we get the value of 0, that means low. Now again move immediate A C0H and execute the SIM instruction, then we get logic 1 from the SOD output and jump again. So we see that logic 0 and logic 1. So if we consider this is an 8085 and this is a SOD line, so from this SOD line 0 1 0 1 0 1 data will be coming out. Okay, and if we insert here some amount of delay, then after some time this delay will be determined the low time and the on time of this output data. So what amount the low time and high time, this should be depend on the delay subroutine program which is used. In the later part will be show that the how delay will be introduced in this type of instruction. And next one is the serial inputted data. So how we will serial inputted data? So that's why in this mode we use instruction RIM to use the input serial data through the SID line. Okay, so instruction RIM can be interpreted for the serial input output to get the serial output data in the 8085, and the data is stored in the first accumulator. Okay, so using RIM, instruction, say consider any peripheral which is sent serially data. This is connected via SID line. This is a SID. Okay, so for ream instruction, this is the accumulator bit pattern. These all are don't care because these all bit are used for the interrupt purpose. This is accumulator pattern for ream instruction. So if we execute the ream instruction, then this D7 bit is get the data from this. This D7 bit is also known as the SID pin of 8085, and we read this status either 0 or 1, and depending on the value of the 1 and 0, we can determine what is the logic present in this serial line which is connected to the any interface devices. This is an interface device through to 8085. So 8085 can read the status of the data either 1 or 0, which is stored in the accumulator, and then it's stored in the another memory address depending upon the programming logic. So this is an overall discussion and the preliminary discussion of SID and SOD pin and SIM and RIM instruction. So how SIM and RIM instruction are executed via to interface the any peripherals which is serially connected and serially data transfer from 8085 to peripheral using SIM instruction, or peripheral to 8085 using RIM instruction. One is for set the values of data or logic 1 and 0, that is from the SOD line serial output data, and using serial input data we can read the status of the serial lines which is connected to the 8085, which peripheral is connected to the 8085. Okay, so what is the advantage of this? The advantage is that we already know that 8085 there are basically 8 data bus are connected, 8 data bus are available. This is an 8085, 8 data bus are connected to the peripheral. So these 8 data bus means 8 parallels were connected from 8085 to any peripheral devices. That is too much hardware complexity to increase the hardware complexity. So to avoid this, we can just use the serial data transfer. So only just one line, just only one serial data lines can be shared the data or to transfer the data from microprocessor to peripheral devices. This is a microprocessor and this is the peripheral. This is our peripheral device. So either transmit from this direction or transmit from this direction. So transmit from this direction via using SOD line, and transmit from this direction we can read the status of the peripheral logic which is transferred to the 8085 using these serial input data pins, and also using RIM instruction. This is done by RIM and this is done by SIM. Okay.